Problem 36, Quantum Mechanics. The question is, the wave function of a particle at a time t equal to 0 is given by ket psi of 0 equal to 1 by root 2 within bracket ket u1 plus ket u2, where u1 and u2 are the normalized eigenstates with eigenvalues e1 and e2 respectively, with e2 greater than e1. The shortest time after which psi of t will become orthogonal to psi of 0. We have to find out the time at which psi of t and psi of 0 are orthogonal. When psi of 0 and psi of t are orthogonal, we can write the inner product of psi of 0 with psi of t equal to 0, and from that we can calculate the time. First, let us write the given state psi of 0, that is psi at t equal to 0, that is 1 by root 2 within bracket ket u1 plus ket u2. The complex conjugate of ket psi of 0, that is bra psi of 0, that is equal to 1 by root 2 bra u1 plus bra u2. Now let us check whether the given wave function psi of 0 is normalized or not. For that purpose, let us take the inner product of psi of 0 with itself. Take the inner product of psi of 0 with itself to check whether the given state is normalized or not. This is equal to 1 by 2 u1 u1 plus 1 by 2 u1 u2 plus 1 by 2 u2 u1 plus 1 by 2 u2 u2. Now we can write it as 1 by 2 into 1 plus 1 by 2 into 0 plus 1 by 2 into 0 plus 1 by 2 into 1, that is equal to 1 by 2 plus 1 by 2, that is equal to 1. Thus the inner product of psi of 0 with itself is 1, means the given state psi of 0 is normalized. So no need to introduce a normalization constant further. Psi of 0 is normalized. Now we have to find out the time at which psi of 0 and psi of t are orthogonal. So to find out time, we have to use the equation, the inner product of psi of 0 with psi of t equal to 0 if psi of t and psi of 0 are orthogonal. From that equation we can find out the time. First let us write ket psi of t, that is nothing but 1 by root 2 within bracket ket u1 of t plus ket u2 of t, where u1 of t and u2 of t represent the time evolution of the states. This is equal to 1 by root 2 within bracket u1 e raised to minus I e1 t by h bar plus u2 e raised to minus I e2 t by h bar. This is because u1 and u2 are normalized eigenstates with eigenvalues e1 and e2. Now we have to find out the inner product of psi of 0 with the psi of t, and since they are orthogonal, the value is 0. From that we can calculate the time. The inner product of psi of 0 with psi of t equal to 0 implies 1 by root 2 bra u1 bra u2, then 1 by root 2 within bracket ket u1 e raised to minus I e1 t by h bar plus ket u2 e raised to minus I e2 t by h bar, that is equal to 0, since psi of 0 and psi of t are orthogonal. Now we can write the equation as 1 by 2, then e raised to minus I e1 t by h bar, then 1 by 2 e raised to minus I e1 t by h bar, then inner product of u1 with itself, plus 1 by 2 e raised to minus I e2 t by h bar, then inner product of u2 with itself. Now from the orthonormality condition, we can say that the inner product of u1 with itself is 1 and the inner product of u2 with itself is 1. Therefore the equation reduces to e raised to minus I e1 t by h bar plus e raised to minus I e2 t by h bar, which is equal to 0. Or we can write e raised to minus I e1 t by h bar, that is equal to e raised to minus I e2 equal to e raised to minus e raised to minus I e2 t by h bar. Or we can write e raised to I into e2 minus e1 t by h bar, that is equal to minus 1. Now this happens when e2 minus e1 t by h bar is equal to pi, because e raised to I pi equal to minus 1. And from that we will see t is equal to pi h bar divided by e2 minus e1. Therefore from the given option, option B is the right option.